This is section 4, rates of change, example 3. For this example, we're actually doing the exact same thing we did in the last example, in example 2. Our equation just changed. It's 5x plus 2, which is actually a little bit easier than the last one. So remember, finding the slope of the secant line is just finding the slope using the slope formula. So we will find f of 4 minus f of negative 1 over 4 minus negative 1. All right, which should be very simple. All we're going to do is take those numbers and plug them into the equation. So when we do, we get 5 times 4 plus 2 minus, don't forget your brackets, 5 times negative 1 plus 2. All over, and then 4 minus negative 1 is 5. Okay, now we do the math. 5 times 4 is 20. So we get 20 plus 2 minus 5 times negative 1 is negative 5 plus 2 is negative 3. So negative 3 over 5. So we get 20 plus 5 because negative makes that positive. So we get, 25 over 5, which is just 5. That's the answer. All right, for part B, we're finding the slope of the tangent line. So remember, the formula for the slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x all over h. We plug in 2 for x, so we have the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. We're plugging 2 plus h into the equation. So we get the limit as h approaches 0 of 5 times 2 plus h. Right, that's what we're plugging into the equation. Plus 2 minus 5 times 2 plus 2. Okay, all over h. So I just took 2 plus h and 2 and plugged it into the equation. That's given. That's all I'm ever doing, is taking what's in parentheses, right? Because remember, this is function notation, and we're plugging it into the function where you see x. If there's more than one x, you will plug it in more than one time. And I'll show you what that looks like too in a later example. So we have the limit as h approaches 0, and we distribute, so we get 10 plus 5h plus 2. 5 times 2 is 10 plus 2 is 12. So we get minus 12 over h. Well, those cancel out because 10 plus 2 is 12, but minus 12 is 0. So we get the limit as h approaches 0 of 5h over h. Well, if I have h over h, those cancel, and I'm really just finding the limit as h approaches 0 of 5. Remember, when you find the limit, your goal is to take 0 and plug it in wherever you see the variable that it's trying to replace. There is no variable that it's trying to replace, so the answer is very simply 5. And then we write the equation of the tangent line, which is y minus y1 equals m times x minus x1. Okay, we have the point 2, and then you plug 2 into the equation. 5 times 2 is 10, plus 2 is 12. Right, that gives you the y value. And m is the answer to part B, which was 5. So the answer is y minus 12 equals 5 times x minus 2.